Morning, David.
How are you?
Good, good. How are you?
Excellent, thank you. Very good. Hey, Rose.
Hi, Rose.
Good morning.
Goodness, we're all very timely today.
We're very what?
Timely.
Yeah, I need to leave at about 10:15.
Okay, well, I'll jump right in then. Have you encountered fixed points before, Rose? Are you familiar with fixed points?
Yeah, I am. In dynamical systems, I've come across it a bit.
Oh, okay. Payam, you've obviously encountered.
Also through dynamical systems, differential equations, that sort of thing. Yeah.
Very simple idea. So basically, the idea I came across from category theory, which also has fixed points. In category theory, they define something called limits, right? So there are these limits that you can basically have in the minimum limit and the maximum limit. And there's something called a catamorphism and an anamorphism. So if you have an isometric structure, you can squeeze it down to a minimum, or you can expand it out to a maximum, right? And so think of a zip file, right? If I have a zip file, I can kind of squeeze it down to some minimum size where I don't lose information, and that is isomorphic to the fully expanded zip file, right? So you can essentially compress and uncompress. And it's interesting that the way they actually work out when you've finished in category theory is that the intervention of compression has no effect. So essentially, if you apply an intervention to the system and it has no effect, you've reached a limit.
Sorry, what's an intervention in a zip file?
A function. If you apply some function to the system, you apply an intervention, you take an action in your action space, to use the reinforcement learning. I see these all as being isomorphic, same thing, but slightly, from different perspectives. So I just wanted to map this into a medical case very quickly. So if you have a patient and you're applying interventions in the form of medicine or treatment or something, and it's having no effect, arguably you could consider that they have arrived at a fixed point, right, where the interventions available in the action space available to them are not having an effect, right? So, I have a headache, I tried sitting in a chair and closing my eyes, I tried waiting a while, nothing happened. None of the interventions that I know of are working. I'm going to take an aspirin, right? I'm going to take a painkiller, right? So when we take the painkiller, what I'm trying to get at is that we lift. Essentially, we have these autonomic system 1 style systems that are running around finding local maxima and local minima, and they're getting trapped there, right? And system 2 is able to essentially look into system 1 and see, maybe through apperception, that nothing is changing in that. And then it can bring into play a whole new range of actions and a new action, kind of high level action space that might lift the system 1 convergence. It might lift the system 1 out of its convergence and essentially get it out of that state and put it on a trajectory, maybe to a new state, or maybe just a trajectory out of that state, and then it will go and get stuck in another fixed point at some other stage. No claim of novelty here. It's just, could we codify this into some sort of a procedure where we could take a system, we could essentially have an algorithm running in the background that is a system 1, in that it's just an incremental reinforcement learning system that's moving around some manifold or optimal control, whatever, it doesn't matter, some inductive process that's creeping around some manifold. And then we have a higher level system that's essentially monitoring its progress. And then if it's unable to move, if its action space is essentially having no effect, then system 2 might have to engage, and you might have to introduce a new range of actions that have the capability of lifting the system out of this fixed point and essentially moving it into another fixed point. And the conjecture I have is that that's essentially kind of like a causal DAG, right? So we could map that out at a higher level to say, if we have a patient who has these conditions and these interventions are not having an effect, we can then go to a higher level kind of book of what should we do, right? And it will have a trajectory. And if you click on that trajectory, it says these patients tried this intervention and had these effects. And so you could build a map that we could use to essentially try and plan out an interventional strategy. And we also have a mechanic by which we can determine when to apply such interventions. Is this old news? I'm guessing it is.
I don't know if it's old news, but I don't know if I accept half a dozen of your
Oh, okay, sure, please,
definitions.
let's tear it apart. We've got Rose for just a few minutes. I'm just curious where she's.
Yeah, yeah.
I'm very happy for her to tear it to pieces. I really am. That would be great.
I guess what I would say is I don't know that it doesn't suffer from the same problems that we keep discussing.
Okay.
And let me just give you some examples. So in this particular case, you're talking about interventions and interventions that could be applied and trying to identify the right intervention. And I think the assumption is that the algorithm is about selecting the right intervention at the right time.
The algorithm can be completely human mediated, right? The algorithm is a human process.
No, I understand that.
Yeah. So I'm not suggesting we kind of completely automate this in some.
No. But I guess the problem, as I see it, is that often it's that the interventions that we don't have other interventions, and we get so locked in our definition of the problem that the interventions actually almost come to define the problem, particularly in healthcare, right? It's gone from where we would try and understand, here is the sort of causal path of what's going on with this patient, and think about what interventions could we possibly take to change that, to thinking about it in terms of, here are the interventions we have, here are the treatments that we can provide. Now, given this patient, what's the best treatment I have? As opposed to
if they haven't reached a fixed point, then you have no idea where they're going without the intervention, let alone with the intervention. So that seems to me to be like.
Tell me what you mean by a fixed point for whom? For the.
So if a child is growing up, we don't apply medication to stop them growing up, because that's a completely natural process which has not reached a fixed point. It's an unfolding process which will may or may not reach a fixed point in the future, but it's just a transitional stage. And I'm not suggesting this provides any insight into what to do if, cancer is progressing, right? You haven't reached a fixed point when cancer is progressing, because the system is undergoing radical change with or without intervention. So I just want to draw that distinction. I'm not suggesting this is useful when you have an evolving situation. That's a different class of problem in my mind, at least. What I'm suggesting is that, you've tried everything and nothing has worked, basically, or the patient has tried all within their action space and nothing seems to have any effect. But maybe I'm mischaracterizing it, and all systems are always in transition. So I don't know.
I guess I think all systems are always in transition, but I guess I'm also feel like I'm missing something else that you're saying. So if you're not getting any response from anything, it's not like you're in a fixed state necessarily.
Sure enough. Once again, these are ill-conceived ideas, so I'm very happy to consider your objections. So in a machine learning scenario, let's switch out of healthcare to a machine learning scenario. If you give a reinforcement agent an action space and it gets trapped in a place, then that's what I mean, right?
So I like that part of it. It's almost like you need to switch algorithms, right?
Yes.
The issue with that is, so this is one example, is like a person walking on a bridge where you can fall on either side, right? Like once you fall, that's a fixed point. By definition, there is no way to get out of it. You're done. if you can get out of it, it's not a fixed point anymore. It's maybe an attractor that you get attracted to, and then maybe you can do other things to get out of it. But if there are any ways to get out of it, it means it was not a fixed point, I think, by definition. So that's one of the issues I had with the whole category theory, because there is no time. So you can only have fixed points or nothing, right? There is no transition, there is no dynamics. So it sort of misses the entire interestingness of the problem, right? It's just like 0 or 1. You're either stuck or you're like got to where you wanted to go.
Sure.
Right?
I know, that's fine.
No, I don't think that's actually correct. I think there are mechanisms that do specify those dynamics and force a convergence towards a fixed point.
Yeah, but once you get to the fixed point, you can't get out of it. That's not a fixed point.
Time has no effect, right? Actions and time, like you've literally reached a fixed point, like nothing changes. So I guess the point I'm trying to get at is that you have this variegation of action spaces, right? So we have prescription medicines, right? And they're not available in the action space of normal people, right? So we have this kind of diminished action space that we're willing to give off to system 1 and say, okay, you know, you can wander around in this way, you know, using these safe steps. And if you get trapped at a fixed point, then I'll notice and I will bring into the play actions that are not available at, you know, at your level to essentially try and get you out of that. That's the kind of hand wavy bit. Maybe this is a dead end. I'm open, but I find it useful.
What you're saying makes sense. I mean, but I guess maybe this is just semantics. It doesn't matter. I mean, maybe as long as you don't call it fixed point, I think it's fine. You're stuck in a state that you don't like, a suboptimal state. You want to do something to get out of it. I think that's totally fine. I just don't see the connection to fixed points in like dynamical systems, because it's not a true fixed points. If it was, there is nothing you can do about it.
Because the action space in the dynamical system is absolute. There are no tiered action spaces in dynamical systems, right? All actions are available to you in a dynamic system, and therefore there is nowhere we can go. So if you reached a fixed point, that's the end of the story.
Yeah, I mean, you can take all the actions, but you won't get out of it. It's like the fixed point is basically your robot is broken or whatever. Right. You're stuck in a hill that you don't have the energy to get out of. So it's an irreversible process. I guess that's my point. But I think you're interested in reversible processes, like correctly.
Well, I'm interested in tiered action spaces, right? So we have
tiered. Okay.
Tiered action spaces, right? So we have a machine learning system, and we give it a learning rate, a maximum learning rate, right? And it will get trapped in the local minima due to nothing other than the fact that its learning rate is unable to escape the manifold that it's getting sucked into, all right? And then we'll apply an intervention at a higher level that will give it a huge learning rate, which will allow it to potentially leap out of this
yeah, it's called momentum, right? That's what all the optimizers, that's what they do, right? That's how it works. So like without it, you would not be able to solve any other deep learning systems, right? Like you give it momentum to basically, as you said, like you give it a kick to kick it out of the local minima, and eventually, ideally, maybe to some global minimum. Yeah,
right.
Yeah,
that's
so
what I'm getting at. Yeah, no. So once again, there's no. Yeah, my point is that there are these two levels of system, right? We have this kind of like if I'm running 1,000 RL agents, and I don't want to have to pay attention to them all. I can run them all, and then I can go back every 5 minutes saying, have you moved? Have you moved? Have you moved? Have you moved? No, you haven't moved. Okay, I'm going to give you a kick, bang. All right, and so there's this higher level sequential process that can look at these sub-processes, make an assessment based on the fact that the action space essentially isn't having an effect, and then apply some higher order intervention. And all I'm suggesting is that the causal DAG might represent some way of representing the higher order interventional structure. That's all. So we can essentially have low-level machine learning systems with incremental kind of inductive action spaces. And then we can have a higher order system, which is like a causal DAG, which says when these systems behave in a certain way, apply, change the action space or the algorithm of the system to see if we can move them out of that. That's all.
So there is a subfield of RL that like we didn't talk about last time. It's called hierarchical RL, which might be getting at what you're talking about. So,
Okay.
so the idea is you have like, let's say you want to like a human being hand, right? You don't go and control every muscle in your hand to lift it, right?
Yes.
So there is some system which may be close to the system one that you talk about that takes care of that. And you take care of the high level actions of, okay, just like imagine you're lifting your hand and it goes up. So people have been trying to do this, but it's really, really hard. And like people don't know how to draw the distinction between the, I guess you call tiers or they call hierarchies. Yeah, so people have been working on it, but as far as I know, it hasn't really gotten very far. Like, I don't know for what reasons, but it's technically difficult, I guess, to learn what is the appropriate hierarchy. Maybe you can hand code what are the appropriate hierarchies, but to learn it is difficult.
I guess it's no different than how we think about things with specialization, right? A lot of what we've been discussing is how you sort of build a unified theory of everything. And within a particular specialty, the elements of your DAG, the way you think about it, the actions, all of that is defined in one way. And you can't always link things across different specialties or different, maybe even different layers of abstraction. It's really hard to map all of that. And so I think it comes down to the fundamental problem of when you reduce something, it's not always easy then to build it back up into wholeness again.
But they've done that with some cases, right? Like a simple, like images we talked about, right? Like, you know, images are a bunch of edges and shapes and textures. Like, so if you have a network that captures that and represents it in a meaningful way, you can build on top of it to look at X-ray images, satellite images, like photo images, they're all the same. But maybe it's much harder for like medicine or like, I don't know how to do it for that.
Right. I mean, I think it's hard for people in general, right? Because that's the fundamental problem, right? How do you know that you have identified all of the things that are truly causal or that play a role, right? And I think I was almost thinking about, or I think about DAGs almost in the opposite way to the way you were describing it, David, that what DAGs give us is the ability to identify the fact that we don't have the full picture. There's something happening here that I am not able to explain using the components that I have already identified. There's something at play here that's still magic. And that's
okay. So that's yeah. So I agree. That to me is the first cause problem, which gets into philosophy and Aristotle and all this other crap. I'm not talking about that kind of causal thing where you're trying to divine the nature of the universe. That's not what I'm trying to get at. So maybe causal DAG is the misstatement I've made, something like that. So what I'm not suggesting we've solved the problem of induction here. What I'm saying is that we can use induction to find fixed points, right? By giving low-level systems a kind of a localized action space, and they can move around and find minima and maxima in their local environment. And then we have some higher order abstraction. Let's not call it a causal DAG. Let's just call it an enhanced action space where we have this kind of bag of really expensive actions that we can apply, which we don't want to. But if the system is stuck, then we are forced to essentially, use some strong action to try and push the system out of this this state. Whether you want to call that a cause or not is, I guess, the conjecture I'm throwing out there. But yeah. I do see a distinction between an inferred cause, which has no a priori, blah, 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 all that stuff. I'm not talking about that. I'm talking about induction. I'm accepting that we can't solve Hume's problem of induction, and we're working in a situation where we only have inductive knowledge. But can we structure inductive knowledge better in some way without getting under the scholastics and all that stuff, first causes? Can we essentially create an intermediate form, which is kind of lightweight causality, which simply says that We have these expensive actions that we don't want to apply, and we only apply them under these constraints. That's all. And if you look at it that way, perhaps that makes more sense.
Mhm.
It's kind of a stepping stone to causal inference. It's not as strong because it's inductive, right? New data could completely shatter it. Interesting. Okay, so that was it.
Another thing that I guess I realized, like when I think I mentioned it before, like I tried to bring up the whole utility of using causal modeling in reinforcement learning with Rich Sutton, who wrote the textbook on it. And he said, why do you need to do that? He basically completely shut it down, said there is no causality, there's no need for it. That's what the agent is actually trying to do. And at the time, I was a little bit surprised, but now I understand what they're talking about, because in a reinforcement learning, like academic setting of reinforcement learning, you get infinite interaction in principle with the simulator or with the world. So if you had infinite interactions with the world, maybe you don't really need a causality, concept of causality. Basically, you try everything that is of interest, and you know what happens, and you put it in your matrix or your model, and you're good to go. There is no need for causality. If everywhere you are in your life, you know exactly what would happen, what you do, because you have simulated it a billion times, then there is no need for coming up with a model or a DAG, because you can think of your DAG as being fully connected. You don't care. You know exactly what's going to happen. So in real life,
you're
like,
assuming you know the actions, right? But the whole point of a DAG is to help you to identify, or in my opinion, the whole point of the DAG is to try and help you to identify what the interventions actually should be. Right?
But interventions are action, and actions are two different things, right? They're not necessarily synonymous. Like they're coming from different fields, they mean different things, right?
Explain the difference to me. I'm not sure I get that.
Like an action, so action, I guess, is more general. It's other things maybe you can do. Intervention is trying to modify a particular connection between two nodes that you have already come up with. Like you give someone a medicine or not. I mean, an action could be
But that's
like,
an action, right? It's an action too.
so I guess an intervention could be an action, but an action doesn't necessarily have to be an intervention.
Well, let's say, for example, the things you eat, right? You're eating every single day. Is that an intervention? Like maybe sometimes it is, sometimes
Well,
it's
it's only an intervention if it's only if in your DAG you have like a connection between food and your outcome. Without it, it's not an intervention. You decide whether or not it's an intervention.
But
if I'm sitting on the sofa and I'm hungry, and I'm really comfortable on the sofa, and I'm kind of sunken into the sofa, it takes an extraordinary act of will to get out of the sofa and go and get yourself a bag of chips or something. But
I don't think it does. It takes an awful lot of will to make yourself get out of the sofa and go for a run. Don't you go to the kitchen and grab a bag of chips?
Not a good example.
I guess that's what I'm getting at. I don't know, you've got to go, Rose. So if you need to.
No, I'm fine. No, I'm sure that's somebody trying to sell me something that I don't want.
Rob, what's your take on all of this? I'm curious.
Well, a couple perspectives. I mean, I think, going back to the start of the conversation, I think the way, at least in my limited experience, medicine tends to work is at best it's in an iterative manner. Let's try this. If it doesn't work, let's tweak it. So in that sense, I think it does kind of map into your framework. But when we think about fixed points, usually when we're talking about them, I think sort of in a more of a theoretical sense, we're talking about something that's much better behaved. So yeah, you could have a localized version of a fixed point. But in general, we're talking about a mapping of one function to another. And so we're making some pretty significant assumptions about sort of the niceness of those sets and the types of functions that we're trying to map. But when we think about sort of what is a fixed point, if you take a simple supply and demand intersection, okay, you can regard that as a fixed point. Now, something might change in the market, and then all of a sudden you've got a different intersection, you got a different fixed point. So is that something that we would call randomness? Is that something that we would call causal? So to jump from one fixed point to another, in an economic sense, trying to keep it simple here, there are lots of things that could trigger that. Yeah, and some of them we would call causal. Some of them we would regard as sort of more random. Okay, now, if we're trying to back out the causal structure, it would seem that we would need to get some form of regularity between the intervention and the associated change in the fixed point. It's not just enough to say it's going to change from this to another. We would presumably want to say, I don't know, yeah, if we cut off part of the supply of oil, the price is going to rise.
Sorry, I'm confused. What distinction do you draw between random versus causal? Because there are no random events. You just don't know the causes of.
Yeah, no, I mean that's a valid viewpoint. But you know, as realistically, what we do is we kind of say, or at least this is sort of what we do in economics and finance. There's actually a bunch of those things out there, and we're too lazy to figure out what they really are, so we're going to call them random.
Unlabeled data, if you will, unlabeled transitions, basically. Right. I mean, machine learning system might be able to identify them. So Rob's given me a bunch of economics data, and one of the things I'm going to try and do is see if we can see if there is any of these kind of repeating transitions. Yeah, but you know, when you look at it kind of from an economics point of view, you've got fixed point theorems for dynamic programming, Bellman type equations. You know, sort of regular price and quantity, or other sort of more sophisticated Nash type equilibria. A common characteristic of those is they tend to have some driving force that pushes you towards that fixed point. Right.
Well, only if you are, I guess, in the basin of attraction of that fixed point.
Yeah, that's correct. You got to be sufficiently local to it, because you can have, I mean, it's not common, but in economic models, you can have sort of multiple equilibria, multiple fixed points. So in economics, the appeal behind the fixed point is that you can say there is going to be an equilibrium in this model. And what that means is it'll sort of be stable, it'll sort of be well behaved around it. And if you can establish a fixed point, then you can prove that, at least in theory, that equilibrium kind of exists. And that at least gives you a focal point for developing a model, in contrast to a place or a model that doesn't have those fixed points. Right. Now, it is true you can have multiple fixed points, and then you've got this interesting transition between them. Right. I'm just trying to visualize exactly what you're saying. So I drew this picture. Right. So we're in a situation here, like we've moved into the fixed point where inflation or something, you know, is causing a problem, and we need to take an intervention. We need to raise interest rates, and we want the system to move out of this fixed point across into this fixed point kind of thing. Right. So we're trying to navigate. We're trying to build a simple map of this manifold, which otherwise is just incomprehensibly, you know, complicated. All we're trying to do as human beings is to create these trajectories that take us from one stable state to another, right? But so I mean, getting back to Rose's world, those would be different health
Conditions, yes.
status.
Yeah, I guess I was also thinking one of the things you mentioned earlier that I kind of like and maybe think there's some value in is the idea of recognizing when you're using the wrong algorithm and you need to switch, right? So right now you come in with a condition, right? And where you start really determines how your condition is defined, right? And so you come in and you mention some symptom or something, and you then get put into a box, right? This is endocrine, this is orthopedic, this is whatever.
Right.
And then that view of the world defines the actions, interventions, whatever we want to call it, the understanding for what's going to happen to you. And very often what ends up, all the tools will be applied, but things aren't really changing. And I think that maybe if you were to have started with a different specialty, the problem would have been defined in a different way. And maybe different actions would have been taken and we might have seen different results. And so I'm wondering if maybe there's some value in what you're talking about in being able to identify where you've kind of hit, maybe not fixed point, but certainly diminishing returns with the approach that you're using right now. And maybe being able to, oh, this is kind of similar to this other piece of this over here. Maybe if you switch the algorithm to try a different set of interventions or a different set of defining the problems, that could be very valuable. You see that with patients all the time where they're like, well, I've been seeing my whoever specialist is for a long time and they think this, and then they go see somebody else and it's like, oh, my problem was something else entirely different. And now I have a whole new set of interventions and way of defining the problem.
Very cool. Oh, very cool. Very
Yeah,
cool.
so I guess the challenging question then is to figure out where to start and how to figure out when to change.
Mm-hmm. So I think recognizing that you're using a particular, like when you're stuck in system one, right? There's nothing else. You're in a finite game. Here are the actions. This is the only way to look at the problem. And then having somebody come in and be like, oh, you're looking at this all wrong. You're trying to use the wrong set of tools for this. Like, here, move over and look at it like this instead.
Mm-hmm.
So we almost need to define whatever our domain is that we're talking about. Here are the different ways of looking at this. This is not that different than the tribe stuff we used to talk about, David. Like having an understanding of, oh, I see based on your language that this is how you're defining this problem right now. And if we can find some overlap between the way you're viewing it right now and what somebody else is thinking about or could be thinking about, it opens up this whole other set of actions, interventions. Yeah, exactly. Yeah.
So do you think the right approach should be like focused on finding the right way of looking at things so that you capture both? Or if there are ways, like, is that something to strive for? Or do you just switch back and forth between 16 different point of views and try to get a little bit out of everyone? What's the I guess
okay, personal opinion or the right opinion?
Let's go with
start with the personal. Yeah.
Honestly, you know what? I think we all do this. You pick your view of the world and you try and make as much coherence as possible. And in medicine, placebo plays a huge role. And so if it aligns with the person for whatever reason, and you can explain things to them in a way that makes sense to them, a lot of the time you don't have to do an awful lot, right?
Reminds me of this episode of, you guys probably seen House, right? House MD, the guy, Hugh Laurie is a doctor. It's like so at some point he's very arrogant. He always thinks he's right. So somebody told him, do you always operate under the assumption that you're completely right? And he says, well, I find it hard to operate otherwise. So which is like, you can't sort of assume you're wrong all the time. You're not going to get anything done. So you always have to assume you're right?
Be an interesting medical profession, yeah.
Like within a framework, right? I mean, I think that's the difference. If you were stuck to a single algorithm for anything you're doing, right? You're going to do some things great, but you're going to completely miss it on a lot of things. And it's being able to recognize, like, you know what, all the tools I have, they're not working right now. Let's try something else, right? Maybe that's the benefit. And unfortunately, the way the medical system is set up with standardization and everything else, there's nobody filling that role right now, right?
Homeopath?
Yeah, acupuncturist, right?
So let's switch very briefly back to Kuhn, because I think he offers some very interesting insights here. What he's saying is that scientific progress comes to fixed points, and that's when we need scientific revolutions. Right? It's the same idea to me, right?
Yeah, agree.
So that's, I mean, I'm just stealing ideas from all these different places and giving them different names, but I think it's useful because I think we can actually get out of this, oh, causality is silly because we don't know what we don't know a priori, so it's just exogenous noise, right? Run away. Okay, we can't run away. We're stuck in an inductive world. Hume was right. But let's work with what we've got and not wish for something we can't get to. And so I'm kind of essentially proposing a weak form of causal inference. It's not as strong. I'm not suggesting it's as strong as a priori, Kantian a priori knowledge or all that cool stuff. Yeah, he's right, Kant's right, but that's not useful to us. We can't use that. It doesn't have an action space I can actually grapple with. So, it's kind of like a cheesy, crappy version of a causal inference, but it might actually provide some benefit.
Yeah, I think it does provide some benefit. I mean, it's kind of experimentation in a way, right? Like you don't always understand why something works, but if at least you're like, oh, well, this is giving better results than something else, then you can start to think about maybe why it's working and what else you can learn about that. Whereas if you refuse to even acknowledge that the way you're defining things right now isn't working at all, right, then you really are trapped.
So how do we go about, I guess, operationalizing this? So like in the Thomas Kuhn stuff, right? Like maybe science is the easiest case because so you're stuck in some paradigm, everybody was Newtonian, classical. Eventually there's enough evidence accumulating that makes it obvious that there is something wrong with the current paradigm. And maybe in the beginning, people try to fix it. They add whatever second order effect to all the models, making them super complicated to fit the new data. But at some point that balance shifts and somebody says, okay, what we have is not right. We got to come up with something completely new. So there you're forced to it, right? It's not a matter of just deciding, okay, we want to do it differently. Like you're forced to it by the reality. But beyond that, like if you want to look into like super complex stuff like medicine or society or economics, like I feel like I wonder if we get into this sort of philosophical thing where, like, in philosophy, there's no progress, right? They just go up and down, up and down. Every generation has their preference of looking at things, and it's not really converging to anything. It's just sort of going in circles. So I'm hoping medicine is more like the science, where eventually there is like a better way of looking at things that help you advance from where you are, right?
I guess what I feel like is happening right now is that we are converging into fatter and fatter tails of like everybody just has everything. Everybody has heart disease. Everybody has diabetes. Like, I mean, I guess personally, the way I think we go about this is either starting with the people who are most vocal that it's not working for them, right? Because at least they can point us in a direction, or looking at outliers, because I think that's where we learn the most. I mean, it gets really muddy in the middle, right? Because it's all kind of similar, and it's you start trying to pick apart things that aren't really that different. Whereas if you can find true outliers, that's where you're like, oh, okay, there's something really unusual here, and it can point me in a different direction.
Yeah, I think that's a very interesting perspective. But I remember it's been a while since I looked at it, but there was some guys at Columbia, Birnbaum or something, who were doing causal reinforcement learning.
No, Elias, yeah. We've all used his stuff, right?
Yeah, so does that?
Yeah, it's great. You just need data.
Yeah, but his papers are like I don't get it. Like you've actually used his stuff. Like he
Oh,
talks
yeah.
about 3 like nodes and he writes equations for like
No,
20 pages.
so I did it with that pyrite project where
Okay.
I did a paper that was presented at AMIA using it. And like in that case, I had some very like objective, right, lab measurements and then diagnoses around that. And I mean, I thought it was useful. Like you can prove that like, okay, the way we're looking at this doesn't make any sense. The theory that's out there that's being used to make medical decisions right now, it doesn't hold up, right? So you can prove that at least, I mean, nobody wants to listen to that, right? But I mean, I think what he does, Rob, is amazing. He is such a smart man. It's like, and he's built tools like that causal fusion, like that allowed me to take my data set and like suddenly I'm able to do a ton in like half an hour rather than having to code the whole thing up myself. I think what he does is very valuable. Huge fan.
Yeah, there is a 2-hour tutorial about if you want to get into all the nuts and bolts. I think he gave a tutorial at NeurIPS a couple of years ago about causal reinforcement learning.
Yeah,
Do you have a link?
Yeah, I can find it.
I used his stuff a lot, and actually his grad students and stuff, like they were coming to me like, okay, tell us what you want to do next. Tell us what you want to do next. It's a really, that tool is awesome. I think it's a great way to just sort of get in, and he's built in super learners and stuff into it too. So you can do a ton really, really quickly just by uploading data. The problem really is data, right? Like if you want to do something in medicine, you need a big data set. If you have a data set, I think there's a lot you can do.
But that again seems a little bit strange because I thought that causality is not in the data set. So if you have a causal model that's correct, technically you don't need any data. You already know the answer. So if you have all the data and no causality, you can do machine learning, but you don't have any causation. So this is sort of the dilemma, right? Unless you can do interventions. Like if you want to actually collect data to influence the collection of data, I think that makes sense.
Well, also what you have to remember in medicine is all about interventions.
Right. So, but do you get the data, I guess?
So which data are you talking about?
So when you say the problem is we need more data, I'm just saying you need a specific type of data. You don't need just more data.
Okay, so we're recording this and I'm like, the people
Right. I work at a university.
the people who have the data, who really have the data and understand what the data actually mean, view the world in a very specific way. That is not working. All right, let's just put that out there right now, right? It's working in some places, it's not working in general. The people who want to change it and use these new tools, they do not have access to data, and any data that they get their hands on, they don't really understand the data semantics.
I see.
Right? If you look at any of these, what are they called? Like aggregation systems that are out there. Like I am in the weeds with our medical system right now, just trying to understand across different medical centers, how do these things mean such different things? So
you need a Snowden of Pfizer, to just dump the entire Pfizer data like in the internet so we can all look at it.
All right, so Rose, this might be a subject for a different conversation, but I really would like to get your thoughts on that in a more structured way.
Only data people are using right now, it's claims data, right? That's what the majority of people are using. Claims is about getting paid. That has nothing to do with what's going on with people, right?
Yeah, okay. But if we can step back, there's a really bigger picture of, so we want to make sense out of the world. We want to create inference models, prescriptive models. And You know, if we can't do it in healthcare, sort of given what we got, it's going to make it really hard to do it in a lot of other areas.
Because so much of medical data is already structured.
Yeah, it's structured, it's labeled.
Mhm.
And, you know, so is it the case that sort of the inherent variability in among the data and the classifications is sufficiently large that it really limits the precision of what you can do?
So
Again,
it's 10:15, I have to go. And
Okay.
so maybe we can have another conversation about this. I'm liking this idea of trying to be a system above that sort of shifts the perspective, right? Just apply a different paradigm to the same problem. I think it's a good idea.
Okay, great, thank you.
yeah, if we need another venue, yeah, I can set that up too.
Okay, why don't we follow up via Slack or email or whatever, and we can talk about what to do next. Okay?
All right, thanks, Rose.
All right, talk to you guys next week, if not before. Bye.
So Payam, I'm very curious to hear your objections. I genuinely am. So can you kind of try and elucidate?
Sorry, about Rose's stuff or about what?
Just in this area in general, like your intuitions are incredibly valuable to me. So I'm very, very keen to hear.
No, I wasn't objecting to the ideas. I guess just to the semantics, because I guess I understood the terms mean different things in different domains. I guess I didn't disagree with any like your program, but what you're trying to do, it makes sense. I guess I didn't understand the whole idea of fixed points, or at least what is it bringing to the, I mean, we all understand local minima. So why not just call it local minima? Why do you want to call it fixed point, which means very different
So in the finite
things?
and infinite game motif, right, we talk about the rules of the finite game. Okay, and typically we have to define externally, exogenously, the rules of chess, right? So that's handed to us before we even start the game. Right. Mm-hmm. So this is the only rule in the finite game that I'm aware of which doesn't require an exogenous source, right? Basically, if you observe a system that essentially has an action space and nothing is changing, you don't need to have a priori knowledge. You can just say, oh, it's reached a fixed point. This is inductive. This is not absolute.
Yeah,
and
no,
so,
I understand. That's fair.
So that to me is the profound insight here, is that we have intrinsic kind of rules that just come for free, right? Like if the agent isn't moving, then we've reached deadlock, right? The game is over, right? So there's no rule for that. I don't have to come in and define a rule for deadlock. It's self-evident. And this is the first self-evident rule I've ever encountered in a finite game, which is nothing's changing, nothing works, I'm stuck. Maybe there are others, I'm very curious.
But again, I guess you guys probably know about the Lorenz Attractor, right? I mean, that's like the first thing you study, like a chaos. Have you seen the?
Now, what is it?
You must have seen this picture. Let me just show it to you.
It's the circle, right? The spiral.
Yeah, so.
It's the 2 points that spin.
Yeah, these ones.
Yeah,
right?
yeah.
So this is like a very simple, like a, you get it in a course in dynamical system, or so basically there are these two fixed points. They are sort of semi-stable, right? So you can
blow that up. Click on it.
Just go.
Right.
Okay, so you got two fixed points, and you've got something that perturbs them and forces them into the other fixed point?
Yeah, so it's a dynamical system, right? You keep taking sort of time steps. And so for a while, you're going to be stuck here. So at that point, depending on what sort of time horizon you're looking at, you might think you're stuck, but you're technically not stuck. You're just waiting for that sort of kick you to this other. I've actually seen this sort of, at least the analogy used for financial markets, right? Like there was a paper suggesting, like maybe you can think of this as a bull market versus a bear market or something like that. Mm-hmm. Like you get stuck in one for a while and then something happens. It doesn't necessarily have to be within the system. It could be an outside factor that kicks you out to the other side and then you stay there. So yeah, so from that perspective, I understand. I guess the only problem I have is like without actually knowing the dynamics, you don't necessarily know that you're stuck. You might just be temporarily stuck. You might be stuck for 1 billion years, or like 5 seconds or 1 second. You just don't know. So that's the only sort of, I guess, so that's something you would not see in a categorical theoretical picture, because you're either, so if you want an actual pure fixed point in a category theory, correct me if I'm wrong, if you are in a fixed point, there is no getting out of it, because there's no time. You've already sort of converged to that, right? Whereas in a real dynamical system, maybe you can argue there are no fixed points unless you're dead. So there's always like a chance of like kicking you out to something else.
So there's a very subtle point I just want to introduce, which is the distinction between objective time and subjective time, right? So one of the reasons I think we've missed this idea in the past is we always think in terms of objective time. And we look at the stock market data, we always have slices in time, and it's absolute time, right? It's universal time. It's not time as perceived by the agent moving through the surface. So an agent at a fixed point essentially is timeless, right? That they have reached this timeless state. But if we look at them in objective time, they don't appear to be timeless because something happened that kicked them out of that in a historical sense, right? So there is it's very subtle. Basically, I perceive that the subjective time of so I'm an agent, right? And for me to take a step forward takes 1 second. Right, so if I take a step forward, that's taking me 1 second, and that didn't have any effect. So psychologically, nothing changed, right? So essentially, time is moving very slowly to me. I'm running and I'm running and I'm running, and I'm really not moving very, very quickly in my own time scale, right? But if you look at it from an objective time scale, or from a different perspectival time, if you will, you won't see it. Like, you literally won't see it, because you'll be observing from a distance and you'll just see that time is ticking away in your world, and the agent kind of slowed down for a while and then they did something else and you don't know why. So I think there is a funny kind of problem here, which is the way in which we look at the fixed point might need to be subjective rather than objective.
Yeah. Everything I said was assuming the objective notion of time. Like, I don't know anything about psychology of time or how it relates to any problem you might have solved. I guess depends on the problem. But yeah, everything I said was, yeah, if you want to consider subjective time, that's a different story. Yeah, maybe you're right. All I said was about the objective.
No, and that's fine. And that's totally fine. I'm not, once again, I'm trying to get different perspectives on this. So that's great. Okay. Yeah, so if you read Leonard Susskind's book on the black hole wars, he talks about this, right? This complementarity stuff, and the perception of time from different agents' perspectives can be radically different. And that's, I guess, where this is also coming from.
No, but that's objective time. That's not subjective time, because there is no simultaneity in nature. The only way.
But it has to be subjective. It can't be objective, because there's no such thing as objective.
Okay,
time.
so I guess then we get into a third kind. Like what you were just describing before this, I thought you mean like a psychological. Like, I'm having a good time. Time is going fast. I'm having a bad time. It feels like I'm stuck. That's different thing from the physics world, where if you are in a 4 light years away, your time is going to be subjectively and objectively different from my time.
Right.
Like, one of us is aging much faster. So
right.
There's,
and
I guess,
so I am
3 different
alluding
kinds.
to this kind of frustration, this other kind of, you know.
Yeah, if you wanted, I guess, bring
it's
in
really
psychology,
expensive for me to
different thing.
walk, and it's not doing anything. So I'm not going to bother walking anymore, because it's not going to have an effect. And I'm not going to do this, and I'm not going to do that. So if all of my interventions do nothing, then I just go into this dead state, right? I'm basically stuck psychologically. And I would argue that is as close as I can come to the kind of time that was talked about in that video that we watched a few weeks ago. So, yeah. So
I guess pragmatically, we all do the right thing, right? Like, if you're stuck in a rut, right, you're not making progress you can think of yourself as an agent trying to solve some problem. If you're stuck, you basically randomize things, and that's what you should do. Like, you try things that you have no idea whether it'll work or not. You just try random things, because you've already tried everything that you thought should work and it didn't work. You're still stuck. So then it makes sense to just try to randomly sample things that you think are unlikely to help, or you have no idea. And that's, I think everybody naturally does that, right? Like if you're bored, you just try random things to shake things up. And I don't see why like machine learning agents shouldn't be doing the same thing, right? It's like the whole exploration, exploitation. Basically, your exploitation is not paying off anymore. You're not getting any rewards doing something that paid off before. So you have to start exploring.
That's a good way of thinking about it. Thank you. That's very useful. Yeah, that's a very good way of thinking about it. Yeah, I agree.
That's what my dog does all the time.
What's that? What does your dog do, Rob?
Epsilon greedy searching.
But what is the epsilon, I guess? Is it 50-50 or?
Well, so we've got electronic fences, and we've got actually parts of the inside of the house that are functionally the same. But they're all predicated on the devices working as well as this collar working. And so, you know, periodically, you know, the batteries run out and he starts, you know, let me get a little closer here. Okay, I'm not getting anything. Let me go a little further.
That reminds me of, so another thing that's relevant, I guess your dog is probably smarter than average dogs, because like there is this concept, David, you probably are very familiar with it, learned helplessness. So there's several like studies of this. So they've done it with monkeys, among other things. So basically exactly what you described, like there's a door, and then if every time you hit it, let's say the bird or the monkey wants to get out of the cage, but then they get electrocuted. After a while, they don't try hitting it. And then you open the door and you leave the door open for like 10 hours, 20 hours. Like you see the monkey just not even trying anymore. Like sometimes they even open the door, the monkey still doesn't try because they expect that we tried this, it didn't work, I'm not going to do it again. So this like learned helplessness is a very sort of well-studied thing in psychology. I think there's lots of experiments. So it's good that your dog, I guess, still takes its chances.
Interesting. Very interesting.
Yeah.
So where I was going with this is that Rob recently gave me a big chunk of very cool financial data, and I was going to, there's this paper which I really like, I'll share it with you. Maybe I'm using overkill here, but I'll just share the paper.
I think you sent the data to me as well. I just didn't have any context, but yeah, we'll look at it.
Where is it? 1 second, I'm just trying to find this. I don't think it's actually. Sorry. Anyway, carry on, guys. Sorry, I'm just hunting for a paper.
I've got a completely unrelated question, but it occurred to me during the discussion today.
Go ahead. Yeah.
Suppose that you know, sort of learned helplessness, or more generally, how our frame of reference is sort of managed by social media.
Mm-hmm.
Is it possible to do what you were kind of describing earlier on, David, and that is to look at the data and uncover whether there are attempts, perhaps directed attempts, intentional attempts to sort of shape or mold.
Yep. You could use it to do that. Yep. Because you could do it before and after. So yeah.
Yeah. So what kind of data would you want to use? I mean, it would be something like there would be a temporal sequence. So I don't know, I'm just making this up. Some social media entity would try and push something.
Right.
And then the activity kind of follows.
Okay. That's a good question. I don't have an off-the-cuff answer. I'd have to think about it, but thank you. That's very useful, and I will chew on that. I don't have a response. Pine might be able to say something.
Yeah, there's a guy. I mean, I don't know if this directly relates to your question, but do you know Max Techmark? So he's a guy. He's a physicist, but now he's been doing machine learning for the last few years. He's at MIT, I believe. I'm just trying to find. So he came up with this new website for news, and it's meant to exactly deal with the bias. So you always get the two sides of the story, and he's developed algorithms to make sure that it's not biased one way or the other. I'm just trying to see. I just shared this article. You can look at. I don't know if exactly what you're looking for, but that came to mind when you mentioned.
I also just posted the link I was looking for.
Yeah, just post his name.
Yeah, put in want unbiased news. This is the Max Techmark thing. It's like a news about it. I don't know where the app is or the website is, but I'm sure they talk about it in the article.
I'll pick it up. Thanks.
Yeah, I think it says improvethenews.org. That's the main app. If you go there, you see headlines sort of, and you can there's like a slider bar. You can say you want more right wing, more left wing, more critical, more friendly. So you can choose what kind of news you want to see. So I think that's pretty cool.
Very cool.
The one you just posted, David, that's actually pretty close to some of the other stuff we were talking about, sort of liquidity clusters.
Yeah, I know. I'm very interested in trying to recognize shapes in time series data, basically. Yeah. So,
well, data in general.
Data in general, yeah.
Time series is particularly tough.
Sure. But yeah, so I'm very interested in trying to do kind of, is it a CNN? I don't know. Maybe it is. Maybe. What do you think, Payam? Is recognizing repeating patterns in data CNN friendly, like the skip network convolutional stuff? I think it is, but
well, I mean, it depends on what you mean by repeated pattern, right? Like if you have a ball that's in several places in a given image, so that's the repeated pattern. So yeah, CNN would be able to let you detect the same object in multiple places in an image. But yeah, but if you
I have to label it, right? I can't just say find coherent patterns in the data. I can't just kind of.
Yeah, these are all supervised. Yeah, so unsupervised. I mean, there is a not new, but maybe like become more prominent in the last couple of years. It's called geometric deep learning.
Yeah,
so they
Benji
basically
published on that recently. Yeah.
Yeah, it's I think Max Welling or I think it's Bronstein. I can't remember his name. So he's the guy, Dutch guy, who's almost written a book. I don't know, they call the paper, but it's like 100 pages. So I've never gotten around. So they basically start with shapes. So it's all about geometry. So they put the entire deep learning or machine learning in terms of shapes. So it's all nodes, graphs, pixels. So they talk about topology of different structures within your data. So I think that might be what you want to, let me see if I can find that book.
There's also, just so that you know, I also posted in the thread in AltDeep a new video series that I'm going through, which I would have to give, like it's up there with Malusky. It's this systems biology lecture series, and it's phenomenal. It's so easy to understand. The lecturer is outstanding.
Where did you
post it? He
also
talks about, it's in the AltDeep stuff.
Okay, I'll check it out.
And he also uses, they use this technique, which I'll let him describe because he does a better job than I do, which also recognizes graph fragments. So very, very interesting. So if you watch like the first 3 lectures, I think it would only take you a couple of hours to get through them. And they're completely watchable, like they're not hyper technical or anything. There's some really good insights related to this as well, but I'm more interested in trying to find fixed points.
Yeah, watch this video. This is, first of all, it's an amazingly done talk. Like, I don't know who prepared the slides for him. I'm pretty sure he didn't have the time or the graphical design knowledge to do this, but it's sort of a talk about that big paper. I think it really motivates, like puts
Oh,
everything.
I've seen this
in-
guy. Yeah, I
in a
watched
film.
him at Neurips. No, I literally
Yeah.
watched him live at Neurips. I know this guy. He's really good. No, it's really good stuff. Yeah, yeah. I'll watch it again for sure.
So he's just gone to Microsoft in Netherlands. He's opened up a new research center in Netherlands to lead it, and he's specifically interested in graph networks for designing new drugs and things of that sort, like biology. But maybe there's some other techniques would be useful for other things.
Yeah, no, I'd also I will watch it. Thank you. That's great. Great. All right, guys. Well, this has been really interesting. Thank you. We're kind of over time, so I need to roll off. But great conversation. I'll think about, and we'll chat amongst us about what to talk about next time. But I think this might be a fruitful kind of segue for us to see if we can actually apply this in some data and see what we can come up with. Maybe we can come up with something that actually works. So
Sounds good.
great. Any other questions or closing comments? Or
Thanks.
that's great. All right, guys, take care. Have a great week.
All right. Thanks,
You
everybody.
too. Bye.
Cheers. Bye.